powering the future. Why quality matters in big batteries. We rely on batteries more than ever. Phones, laptops, even our cars need them. Now, imagine batteries the size of rooms powering our homes and cities. That's where battery energy storage systems, or BESS, come in. These big batteries are game changers for clean energy, but they got to be built right. Quality assurance, or QA, is like a strict teacher, making sure every step of the process meets the highest standards. We use key performance indicators, or KPIs, think of them as report cards, to track how well we're doing. From sourcing materials to recycling, every stage counts. Why all the fuss? Because reliable BESS means a brighter, more sustainable future for all of us. Starting strong. Checking the ingredients in battery building. Building a BESS starts long before the assembly line. It begins with sourcing the right stuff: lithium, cobalt, nickel and more. We're talking about the core ingredients of batteries, and quality matters from the get-go. That's where supplier audits come in. We're not just taking their word for it. We send in the inspectors to check their processes, their safety standards. The whole 9 yards. We're also testing those materials rigorously. Is the lithium pure enough? Does the cobalt meet our standards? Every batch gets scrutinised. Our KPIs track everything, from supplier performance to material defect rates. It's about making sure we're starting with the best possible ingredients. Building blocks. Making sure battery cells are top-notch. Think of battery cells as the heart of a BESS. These individual units store the energy, and they need to be built tough and reliable. That means intense scrutiny throughout the production process. In-process checks are like pop quizzes during manufacturing. We're constantly monitoring things like electrode thickness, electrolyte consistency, you name it. Any sign of trouble, and we hit the brakes. Leak testing is another critical step. We're talking about high voltage systems here, and any leaks can spell disaster. Specialised equipment checks for even the tiniest imperfections. KPIs for this stage are all about precision and performance. We're tracking cell capacity, internal resistance, and more. Every cell that makes the cut has to be a champion. Teaming up. Putting battery cells together right. Once we have our A+ battery cells, it's time to assemble them into modules, the next level up in the BESS hierarchy. This is where automation and human expertise work hand in hand. Automated cell matching is key. Every cell has slightly different characteristics, and we use sophisticated algorithms to create modules with optimal performance and lifespan. But technology alone isn't enough. We use X-ray inspections to peer inside the modules, ensuring connections are perfect and there are no hidden defects. Our KPIs for module assembly focus on consistency and reliability. We're tracking things like module capacity variation, temperature distribution, and more. Every module needs to be a team player. Section 5. Getting connected, making the battery pack safe and powerful. Now we're talking serious power. Multiple modules get connected in series and parallel to form battery packs, the heavy hitters of the BESS world. Safety and performance are paramount. Electrical isolation testing is crucial. We're talking about thousands of volts, and any stray currents can be dangerous. Rigorous tests ensure everything is properly insulated and safe to handle. Thermal imaging helps us visualize heat distribution within the pack. Hotspots can indicate potential problems, so we're looking for any anomalies that need addressing. KPIs at this stage are all about safety and power. We're monitoring insulation resistance, pack voltage, and temperature fluctuations. These packs need to be workhorses, but safety is always job one. Section 6. Power play, making sure the battery's brain works perfectly. A BESS isn't just a dumb battery, it's a complex system with a brain, the power conversion system, or PCS. This is where the magic happens, converting DC power from the batteries to AC power for the grid. Efficiency tests are crucial. We want every watt of power to count, so we're measuring how efficiently the PCS converts energy. Every percentage point matters for overall system performance. EMC testing, or electromagnetic compatibility testing, is another critical aspect. We need to make sure the PCS doesn't interfere with other electronic devices and that it can handle interference from the outside world. Our KPIs for the PCS focus on efficiency and reliability. We're tracking things like conversion efficiency, power factor, and harmonic distortion. This is the brains of the operation, and it needs to be firing on all cylinders. Section 7. Suit up. Protecting the battery from the elements. BESS installations can be massive, often housed in outdoor enclosures. That means they need to be able to withstand the elements. Rain, snow, heat, you name it. That's where containerization or housing comes in. Structural tests are key. We're talking about simulating extreme weather conditions, high winds, heavy snow loads, to ensure the enclosure can handle whatever Mother Nature throws at it. Environmental sealing is another crucial aspect. We're talking about keeping out dust, moisture, and even pesky insects. Specialised gaskets and seals ensure a tight, weatherproof barrier. Our KPIs for containerisation focus on durability and protection. We're tracking things like structural integrity, water ingress, temperature stability within the enclosure. It's all about providing a safe, reliable home for the BESS. Section 8. Smart battery, safe battery, keeping data secure and under control. Modern BESS systems are smart systems. They generate a ton of data, and we use that data to optimize performance, diagnose issues, and ensure safety. But with great data comes great responsibility. Software validation is paramount. We're talking about rigorous testing of the software that controls the BESS, ensuring it's reliable, efficient, and does what it's supposed to do. Cybersecurity is another critical aspect. These systems are connected to the grid, and we need to protect them from hackers and cyber attacks. Robust security protocols and constant vigilance are essential. Our KPIs for control and monitoring focus on data integrity and system security. We're tracking things like data accuracy, communication latency, and security breach attempts. It's about making sure the BESS is smart, safe, and under control. Section 9. Game on. Testing the battery's limits. We've built our BESS, checked every component, and now it's time for the big leagues, system level testing. This is where we put the entire system through its paces. Performance testing is like a marathon for the BESS. We're talking about simulating real-world operating conditions, charging and discharging at different rates, responding to grid signals, to ensure it can handle the demands of the grid. Grid simulations take things a step further. We're replicating real-world grid conditions, voltage fluctuations, frequency changes, to see how the BESS responds. It's like a dress rehearsal before the main event. Our KPIs for system-level testing focus on overall performance and grid interaction. We're tracking things like energy efficiency, response time, and grid synchronization. It's about making sure the BESS is ready to perform when it matters most. Section 10. On the road and ready to work. Moving and setting up the battery safely. BESS installations can be big, think shipping containers or even entire buildings. Transporting and installing these systems safely and correctly is a critical part of the process. Shock monitoring during transportation is essential. We're talking about using sensors to track impacts and vibrations during shipping. Any rough handling can damage sensitive components, so we're keeping a close eye on things. Site assessments are crucial before installation. We need to make sure the site is properly prepared. Level ground, adequate ventilation, proper electrical connections. A successful installation starts with a solid foundation. Our KPIs for transportation and installation focus on safety and precision. We're tracking things like shock and vibration levels during shipping, installation time, and commissioning checklist completion. It's about getting the BESS where it needs to be, safely and efficiently. Section 11. Power up. Making sure the battery is ready for action. The BESS is on site, connected, and ready to go. But before we flip the switch, we need to make sure everything is working as it should. That's where commissioning comes in. System validation is like a final exam for the BESS. We're running a battery of tests, checking communication protocols, verifying safety systems, ensuring grid synchronization, to make sure everything is working in harmony. Performance tests during commissioning are crucial. We're checking the BESS's ability to charge and discharge at different rates, respond to grid signals, and perform under various operating conditions. It's about making sure it's ready for prime time. Our KPIs for commissioning focus on system functionality and performance verification. We're tracking things like test pass rates, system response time, and energy efficiency. It's about dotting the I's and crossing the T's before the BESS goes live. Section 12. Keeping the juice flowing. Battery care for the long haul. A BESS is a major investment, and like any piece of complex equipment, it needs regular care and maintenance to ensure it runs smoothly for years to come. Data analysis plays a key role in maintenance. We're constantly monitoring the BESS's performance, looking for any anomalies or trends that might indicate an issue. Early detection is key to preventing costly downtime. Preventive maintenance is like taking your car in for an oil change. We're talking about regular inspections, cleaning, and component replacement to keep the BESS in tip-top shape. Our KPIs for operation and maintenance focus on system uptime, reliability, and performance optimization. We're tracking things like system availability, mean time between failures, MTBF, and energy efficiency over time. It's about getting the most out of the BESS investment. Section 13. Recycle, reuse, repower, giving batteries a second life. Even the best batteries don't last forever. But that doesn't mean they're destined for the landfill. End-of-life management is crucial for ensuring we dispose of BS responsibly and sustainably. Decommissioning is the first step. We're talking about safely removing the BESS from service, discharging it properly, and preparing it for transportation to a recycling facility. Material recovery is the name of the game. BESS contain valuable materials, lithium, cobalt, nickel, that can be recovered and reused in new batteries. Specialised recycling processes help us minimise waste and reduce our environmental impact. Our KPIs for end-of-life management focus on responsible disposal and resource recovery. We're tracking things like the percentage of materials recycled, transportation costs, and adherence to environmental regulations. It's about closing the loop and ensuring a sustainable future for BS technology.